Kasi baka matagal mag-present.
Sige.
Christian, ikat mo yung kay Arian hanggang doon lang sa bago mag-solving.
Sige, ulit na ulit ako. 1, 2, 1, 2, 1, 2, 3, go. So, good day everyone. My name is Arian Jeremy Macaklay, and today we'll be talking about one of the application of derivatives, also known as related rates. Here on our learning targets, we have two learning targets, which is number one, able to understand the definition of related rates, and number two, to be able to solve the related rates problems. So, what is related rates? So, the definition of related rates related rates is the rate at which quantity is changing by relating it to other quantities which are rates are known. So, halimbawa, imagine you have two clocks which are ticking at the same time. Pwede mo makuha yung information from one clock para malaman mo kung ano yung nangyayari sa other clock. So, ayun yung isang one real-life situation sa related rates. So, moving on solving or how to solve related rates problem. Moving on sa pag-solve ng related rates. So, number one, draw a picture if needed and identify the quantity you are looking for. So, minsan sa mga problems sa pag-solve ng related rates, kinakailangan i-draw natin yung picture para mas ma-identify natin kung ano ba talaga yung hinahanap doon. So, number 2 naman, we have here identify the given information or problem. The rate of change are also described as over here. Derivative of a particular variable with respect to time. Na-identify natin dito yung change o kaya naman yung sign ng ating quantity kung pwede ba itong maging increasing o kaya naman decreasing. Pag increasing, ang sign natin dyan is positive. Pag decreasing naman, negative siya. So, ganyan. So, if naman kapag yung rate natin is decreasing, lalagyan natin yung quantity ng negative. So, moving on naman tayo sa step number 3, which is identify the equation that relates to the variables. Meaning, dapat, para ma-solve natin yung related rates, dapat alam natin kung ano yung formula ng given equations or kaya naman dapat alam natin yung equation ng iba't ibang figures or alam natin yung formula ng iba't ibang figures. Sa number 4 naman, dahil with respect to time, lagi, or mga rates of change natin, kung mapapasin nyo, lagi natin ginagamit dito yung derivative of a particular variable with respect to time. So, ayun yung lagi natin gagamitin doon. So, tapos, after naman nun, sa number 5 naman, syempre, alam na natin kung ano yung gagamitin na formula doon. Ang gagawin na lang natin is isa-substitute natin yung mga given rates o kaya naman yung mga given values sa derived equation. Tapos, step number 6 naman natin is doon na natin isosolve yung overall na hinahanap doon sa mismong problem sa related rates.
So, good day everyone. I'm Casey Machas and I'm talking about how to solve a problem in related rates. So, we have problem number 1. A right cylindrical tank is filled with water. The tank stands upright, has radius 20 cm. How fast the height of water in the tank drop when the water is being drained at 25 cubic centimeters per second. So we have the picture here of cylindrical tank. And yung unang kukunin natin is yung height or yung upright ng tank natin, which is yung 20 cm, yung radius. Then, kunin natin yung isang given, yung dV over dt over, magiging negative 25 siya since ang pinag-uusapan is drain. So, negative 25 cubic centimeter per seconds. And ang hinahanap natin is height. So, ang hanapin natin is dH over dt. So, solve na natin. Gamitin natin yung formula natin sa cylindrical. Pi r squared times height. So, yung R natin, yung radius natin is yung 20. Then, 20 squared times height. Then, si pi natin, ililipat lang natin siya dito. Then, yung 20 squared natin, ililipat natin sa unahan. So, 20 squared is 400 pi times height. So, para makuha natin si height, kailangan na natin ipasok si negative 25, yung dv over dt. So, dv over dt, bring down natin si 400, kasi 400 pi. Tapos si h, yung height natin, gagawin natin siyang, eto, dh over dt. So, si dv, papalitan natin siya ng given niya, which is negative 25. Then, si 400, bring down lang natin. Tapos, si dh over dt. So, para ma-cancel si 400 pi, kailangan natin i-divide si negative 25 ng 400 pi. Then, i-cancel natin si 400 pi. So, kailangan natin i-divide si negative 25 over 400 pi. So, ang kakalabasan is dh over dt is negative 1 over 16. So, ito yung height natin na yung height of water in the tank drop when the water is being drained. So, lalagyan natin siya ng cubic centimeter per second. So, ito yung final answer natin. Ibig sabihin, yung height ng water natin pag nade-drain is negative 1 over 16 cubic centimeter per second. So, let's move to problem 2. Gorna. So, let's move to problem number 2. A spherical balloon is being inflated at the rate of 10 cubic centimeter per second. How fast is the radius increasing when it is 5 centimeter? So, may given na tayo na una, which is yung radius natin, 5 centimeter. Radius equals to 5 centimeter. So, kunin natin ulit yung mga given. Yung radius na 5. Then, si dv over dt equals 10 cubic centimeter per second. So, ang hinahanap natin dito is yung radius ulit. Pero yung radius increasing. Ano daw yung radius pa nag-i-increase yung spherical balloon? So, solve na natin. So, yung formula natin dito is yung V equals to 4 over 3 pi radius cube. So, paano natin nakuha si 3? Si cube natin, ibababa lang natin siya sa tabi sa gitna ng pi and ng radius. Then, babawasan natin si cubic ng 1, so magiging squared na lang siya. Ika-cancel natin si 3, since same lang naman sila. Then, si dv, yung given natin na 10. So, 4 na lang tira dito. 4 pi then yung radius na given natin, which is yung 5 squared times dr over dt. So, pi 5 squared is equals to 25 times dr over dt. So, si 10. Ita-times natin ito. Si 4 times 25 which is 100. 100 pi times dr over dt. So, para ma-cancel natin si 100 pi dito, kailangan natin sila gagawin natin sa decimal si 100 pi. So, 1 over 100 pi. Then, lipat natin si dr sa pinakauna. Dr over dt. So, magiging 10. Then, i-cancel na lang natin to para mas mabilis tayo. Cancel natin. Mali na naman ako. Ano ba, Casey? Ba't ko kinancel to? Bobo. Ulit nga. Kinancel ko? Bobo. Sige. So, bababa lang natin si, i-times lang natin si 10 times 1. So, magiging 10 over 100 pi. So, isi-simplify lang natin si 10 over 100 pi dt over 1 over 10 pi. Centimeter per second. So, ito yung final answer natin. So, ang radius daw natin, pag nag-i-increase yung spherical balloon is 1 over 10 pi centimeter per second. So, thank you everyone. Aryan?